Hello everyone, it's a pleasure to invite you for my mathematics class. This is a problem in two-dimensional random variable. It's a two-dimensional continuous random variable in the sense that this is the probability density function which is given as cx into x minus y, and that x takes the values from 0 to 2 and y is taking the value from minus x to plus x, and hence this is a two-dimensional random variable, continuous random variable, and that we are asked to find the value of c and the marginal density function of x and marginal density function of y and the conditional probability of y given x. We have to find the conditional probability of y given x. So these are the four questions that we have to answer using this probability density function. I have explained things well in my previous classes wherein I have handled this two-dimensional continuous random variable, wherein I stated very clearly that for doing problems or finding the various probabilities depending on the questions, you have to determine the region or the domain in which we have to calculate the probability. See, so what I mean here is that first of all you must be able to draw the diagram of this. See, this is what you have. This is your x-axis. This is your x-axis, this is your y-axis, and that you are given, see, given f of xy. Of course, this random variable xy is here. It is always denoted like that. Cx into x minus y in the interval 0. I will put it here. See here. Let me put like this: 0 less than x less than 2 minus x less than y less than x. Now that means that you have to draw the domain of this. See, this is your x-axis, this is your y-axis, this is nothing but 0 to 2, 1, 2. So draw a line like this. This is your, now as per this is x is less than or equal to, actually x is less than or equal to 0 means x less than 0 means x greater than 0 means all the points lying to the right of this origin. This is your origin, and below 2. So this is the area in which the x is lying, and the values of x lie only in this region, and this one is x minus y. So this is nothing but what? You draw this line. That means you draw the line y is equal to minus x and y is equal to plus x. Y is equal to plus x is this 1 1. Here it is 1 1 and 2 2. So this is your 2 2 and this is what? 1 1. And another line is y is equal to minus x. So you take like this. So this is 2 minus 2. Now you see that this is the region. This is the, can you see this? So this is the region. This is the region. I will call this as your O, A, B, C. So you see that your OABC is the region or the domain over which you have to evaluate the integral or find the various probabilities. Here you see that you have to find this one marginal density of x, marginal density of y, and the conditional probability of y of x, y over x. So all these things have to be done only in this domain, and not elsewhere, and that you are given that this is what you are given, and also additionally you are given is equal to 0 otherwise means beyond, that is besides this region nowhere else this f of xy is defined. In all other places it is 0 only. So this is the basic understanding of the problem. First of all, you must be able to understand what the problem says, then you have to start doing this. So these are the basic things that you must understand. Next thing is, now you see that we know that, I will write here, we know that double integral of on the domain your f of xy dx dy is equal to 1. That means you see that the integral value of this probability density, see this can be, because this gives you the sum of the probabilities. You must know that this gives you the sum of the probabilities over this domain, and you must know that f of xy, this is the probability density function, this is always greater than or equal to 0, and that its summation over this area is equal to 1. So these are the two things that you must know. Now let us apply this and get the value for C. What is C here? So you are asked to find, evaluate C. Now therefore this implies, I will simply write here, this implies it is C x into x minus y into dx dy or dy dx. I will call it in any way. In both the ways you will get the answer. So this is equal to 1. Now you have to fix up the limit. Now you see that I am going to integrate with respect to y now. So y ranges from, say y will be here. So y will go from here to, see that. You have to sweep the full area. Can you understand? This is double integral, means it is the area. Now this y has to sweep the full area from full area which is with respect to itself and y. That means you see that here this will be like this. Here it is y is equal to minus x, and here y is equal to plus x, and this this strip will be just sweeping over this till it reaches 0 to 2 of x. Can you understand? That means this strip it is going from minus x to plus x. Anywhere you take, it will be minus x to plus x. This will move forward and forward, and see that it sweeps the full area. By when it sweeps the full area, x would have traveled 0 to 2. That means your y is from minus x to plus x, minus x, and x is ranging from 0 to 2. Can you understand what I mean here? So you have to integrate over the region. When you integrate over the region, you must be able to fix the limits of the lower limit and upper limit of y, and also with respect to x. Now you see that when you are going to integrate, when you sweep, see what is that? Minus x, this strip minus x to plus x will sweep the full area extending from what? 0 to 2. That is for x. So the limits are 0 to 2 and minus x to plus x. So this is equal to 1. So this implies, take that c outside, 0 to 2, I will integrate x squared. If you integrate with respect to y, it is x squared y, then minus x, if you integrate with respect to y, it is 2, and it is going from minus x to plus x into dy dx is equal to 1. So I will put like this. So this implies, what does it mean? So c into 0 to 2, and you apply the limits here. If you put here x, it will be x cubed minus x cubed by 2. Keep this in a bracket. Then minus the second limit. If you put minus x, it will be minus x cubed. Then minus, if you put minus here, it will be plus. So again it is minus x cubed by 2. So into dx is equal to 1. So this implies c into 0 to 2. Now this is minus x cubed by 2. This is plus x cubed by 2. This minus into minus will be plus. So it will be 2x cubed. So this you get 2x cubed into dx is equal to 1. This implies 2c into integral of x cubed is into x to the power of 4 by 4, 0 to 2 is equal to 1. So this implies 2c into, if you put x is equal to 2 means 4, it is into 4 is equal to 1. This implies 8c is equal to 1. This implies c is equal to 1 by 8. So you see that this is what you get. So what is the value of this c that you get here? So the value of c is 1 by 8. So this value is 1 by 8. So we have got the value. So this is how we calculate. So understand that the basic idea of this is that the double integral of the probability density function over the domain in which we are concerned must be equal to 1. So you get the answers. Okay. Now let us go pause on to the next one. See what is the next one here. You are given the next one is the marginal density function of x. To find fx of, this is called marginal density function of x. This is called marginal density function of x or MGF of x. So this is called your marginal density function of x and is given by, we know that fx of x, this is a formula like it is minus infinity to plus infinity f of xy into dy. So you see that this is the limit of this is minus infinity to plus infinity. But understand that this is a formula like, so I will put it in inverted commas. But this minus infinity into plus infinity is generally speaking. But you are concerned only with the what? Your problem is concerned with a particular domain there. So this limit must be accordingly as per the problem. So here f, this is fx of, see, fx of x is equal to, so this is nothing but what? I will put it like this, cx into x minus y into dy. Understand that if you want marginal density function of x, then the integral must be with respect to y. If you want, and if you want the marginal density function of y, the integration must be with respect to x. So you see that fx of x is equal to this much. And what is this? So in this particular domain, this whole of this O, A, B, C, x varies from what? Your y, that is y varies from minus x to plus x. It sweeps, it goes from minus x to plus x. So it is minus x to plus x. Now therefore this is equal to, so this implies this is equal to, now put this value here. So what is that here? I will put it here. So take that c outside and you integrate with respect to y. So this is x squared y minus xy squared by 2, and the integration limit is minus x to plus x. So this is equal to c. If you apply this first limit, it is x cubed minus x cubed by 2 minus, if you put minus here, minus x, that is y is equal to minus x, then minus x cubed. Minus, if you put minus x here, it will be a plus x squared, it is minus x cubed by 2. So you take this, that is 1 by 8 into x cube. This is minus x cubed by 2, this is plus x cubed by 2, will go off, giving you 2x cubed. So this is 2x cubed, that is equal to 1 by 4 of x cubed. So you see that I am able to get the value of this marginal density function as this. That is, I will write it here. That is fx of x is equal to 1 by 4 of x cubed in which interval? So this has to be integrated. Now you see that you have to fix the limit for x in the limit of x. So what is the interval for which in which this x is evaluated? So this x is ranging 0 less than x less than 2. So this is the answer. So what is this? This is the answer. So what is your marginal density function of x? It is 1 by 4 of x cubed into 0 less than x less than 2. So this is what we get. And incidentally, try to understand that if you are going to integrate with respect to, if you are going to integrate this, that means this is a probability density, marginal density function with respect to x. If you are going to integrate this over this 0 to 2, you must naturally get 1. You will get 1. Okay. Let us not give up. Let us not do that. It is not a part of the problem. That is why I am not doing it. So I have found this. So this value has been found. So this is over. This is over and this is over. Now let me come to the third one. What is your third one? See, your third one is nothing but your conditional probability of y with respect to x. Conditional probability of y with respect to x. So this is nothing but your 1 by 4 of x cubed. So this is 1 by 4 of x cubed, 0 less than x less than so. So this is the answer. So this is what. Now let me come to this. So what is this? This is nothing but the conditional probability. See, I'll write here. We know that the conditional probability of probability function of y given x is, it is like written like this, probability of y, conditional probability of y with given x is equal to divided by and so these two things you must know. So f of, so these are the two things that you must know. So these are called conditional probability of y given x. This is the conditional probability of x given y. So this is what I mean. So this I will put it in a bracket. So this is what is we wanted. So this is, we have to find what is the value of this. The meaning here, this is a conditional probability of x given y. So this is the conditional probability of x given y. Now let us find out what is the value of this. So I'll rub off this. I don't want this. This is not asked. You can do in your own interest. You can do all those things. I will tell you what are the things that you can try. Okay. Let me come to this. So you see that we will find the value of this. Now what is this? So this is equal to what? F of xy. What is your f of xy now? It is c into, this is x into x minus y divided by, what is your f of x? F of x is nothing but your 1 by 4 into x cubed. So this is equal to 1 by 8 x into x minus y divided by 1 by 4 into x cubed. So this 4 will go to the top, 4 by 8, 4 by 8. So x will go off. So it is x minus y by x squared. That is equal to half into x minus y by x squared in the whole of this 0 less than x less than 2 minus x less than y less than x. So this is what you have here. That is your conditional probability of y given x is half into x minus y divided by x squared, and in which domain? 0 less than x less than 2 and minus y this. So this problem is also answered. So what is this? So here you see that the answer is half x minus y by x squared, x minus y by x squared, and which is this is 0 less than x less than 2 minus x less than y, and this is your half y by x. So this is what we have. So I have found the value of this also. So this is over, and let me come to the last one. So this is also over. So this is also. Now let me come to the next one, final one, which is the marginal density function of y. Now what is that? We know that I will write here. I have taught you that, so I will put everything here. So I will rub off this also. Now what is your f of fx of? We know that f marginal density function of y is given by, see, it is integral of this into f of xy into dx. Now you see that here there are if you are going to find x means you are going to see there are two domains that you have got. I have to calculate two domains in which this probability density marginal density function of x is y is defined. This marginal density function of y is defined in two domains. Here it is that d1 and d2. d1 I will split it into d1 and d2, and that this fy of y, that means marginal density function of y, has to be calculated or has to be found in the domains d1 and d2. Unlike the marginal density function of x could be got by just taking minus x to plus x throughout. But here it is not like that. Either you have to go by, either we can take it in, that is you have to find the marginal density function of y in this domain, and also how does the marginal density function looks like in this domain d1, and how does it look in the domain d2. So you will have two marginal, that is the two values for the marginal density function of y. Now you see that I will write it here. So this is the one when this is so I will put it in this way. So I will write in this way so that you will understand. See, f y of y will be equal to, it will be in the first one, it will be on d1. See, in d1 what happens is that in d1 here you see that see, this is nothing but, first write like this, f of xy into dx. So x takes the value, so it is like this, it is going like this. So x takes the value plus y to 2. X takes the value. So if you want, I can just rub off this and teach you. So you see that this is your d1. So you draw a line parallel to y-axis. So d1, let me call this as your d1. What is happening in d1? X is taking the value y and it goes up to 2. So I will write here. So I will write here fy of y is on d1 f of x dx. So this is equal to, it is in the domain 1 means x takes the value y to 2, x takes the value from y to 2, f of x y dx. Likewise, f of y is equal to, it is d2 f of xy dx, and this is equal to x is equal to minus y to 2, it is f of xy into dx. So you see that I have to put here, it is x taking the value y. So what will happen here, if you put 2, it is 8 by 3 minus 8y. Then if you put y here, it is y cubed by 3 minus, if you put y here, it is y cubed, so it is y cubed by 2, y cubed by 2. That's all. So you see that this is equal to, I'll take it as 1 by 8. This is 8 by 3 minus 2y. This is LCM is 2, 3, 6. So this is 2 minus 1. So this is plus y cubed by 6. Y cubed by 6. So when you take this 1 by 8 side, so 1 by 3, it is 1 by 3 minus 1 by 4 of y plus y cubed by 48. In which interval it is? So this is happening in this interval, namely 0 less than y less than 2. 0 to 2, in the interval 0 to 2. And now then it is minus y to 2 cx into x minus y dy. Of course it is dx. That is equal to 1 by 8 into, so same thing, x cubed by 3 minus x squared y by 2, and this is from minus y to 2. X takes the value. So you see that this will be again 1 by 8. This remains the same, 8 by 3 minus, it is 2y minus, if you put minus y, it is minus y cubed by 3 minus, if you put minus y, it is plus y squared, so it is minus y cubed by 2. So this is equal to 1 by 8 into 8 by 3 minus 2y. See, this is minus and this is also minus, so it will become plus. So it is 5y cubed by 6. That is equal to 1 by 3 minus 1 by 4 of y plus 5 by 48 y cubed in the interval. Which interval? It is minus 2 less than y less than or equal to, you can put less than or equal to 0. So you see that these are, so you have got two values for this f of, that is marginal density function of y, because it is defined in this interval and also in this interval. So what is the answer that you get here? It is fy of y, y to 2. I will write the answer here. So what is that you will get here? So this will be equal to, first one, it is 1 by 3 minus y by 4 plus y cubed by 48 in the interval 0 less than y less than or equal to 2. And for this is equal to, what is that? It is 1 by 3 minus 1 by 4 plus 5 by 48 of y cubed, 5 by 48 of y cubed in the interval minus 2 less than or equal to y less than or equal to 0. So this is, well, so you see that we are able to get the answer for all these things. And so this is the marginal density function of y, and it is and we have to find it in two different domains, and we are able to get the answer. So this is how we do it. And if you must be able to know the formula like f of xy. If you want to prove that it is that is valid probability density function, then integrate over the region, find that its value is equal to 1. Using that idea only, we are able to get this value of c. And then what is this? This is the marginal density function of x, whose formula is given by f of x will be equal to integral of f of xy into dy, and you have to fix the limits. And likewise fy of y, this is the marginal density function of y, and it is the integral of this one, that is f of xy into dx, whose limit has to be properly fixed. That is what I have done. And then this is the conditional probability. It is nothing but f of xy divided by, and if you are asked to find the conditional probability of x given y, then it is f of xy divided by f of y. That is the marginal density function of y. You will get the answer. So this is all about this problem. This is a standard problem. Normally they are asking university examinations. I will do more number of problems in the coming days. Thank you.